All right, this is exciting. You're about to start your calculus career, and we're going to start off with the concept of limits. Limits, you'll find out as you go through calculus, are secretly hidden behind almost everything you do in calculus. And what we do today, it's going to be kind of just pictures and graphs and doesn't appear to be much math, but that's just because we're getting used to a brand new concept. And believe me, you won't have to wait long and there'll be some serious math going on behind here. So I've created a really goofy looking graph of f of x. You notice that it has a lot of weird characteristics. That's to help you learn about all the different nooks and crannies that you find in limits. And as we're going through this, I have a very informal definition over here that you should keep running through your brain. It says the limit value is the y value that is being closed in on or approached as the x values get closer to a specific location. So let's take a look at that. This very first question, I would read it like this. The limit as x approaches 0 of f of x. And this tells you we care about the x value of 0, so we're closing in on an x value of 0. And we're paying attention to the y values of f of x. And the y value that's being closed in on, that will end up being our answer. So in this case, as I get closer and closer to 0 on the x-axis, I look at it like this. I'm going... Notice that every single one of those little dots that I'm putting onto my graph, I'm closing in closer to an x value of 0. For example, right here I'm at an x value of about -2.5. Now I'm at an x value of -2. Now I'm at an x value of -1. And now I'm getting very close to an x value of 0. So x is closing in on 0. As I'm doing that in this very basic case, it's pretty clear what's happening to my y value. My y value is getting closer and closer to 5. So my answer here is 5. Now conveniently, someone else might have looked at it from the other side and they might have snuck up on an x value of 0 by coming from this side. We're going to talk about that here shortly. But the main focus here, and think about this sentence over here, as my x values keep getting closer and closer to 0, my y values are getting closer and closer to a certain value. And in this case, that value happens to be 5. So this limit answer is 5, but I've actually kind of glossed over the real calculus rule, so let's get a little more in depth. Now if you look at this problem, it looks like it's almost the same as the previous one, but this says limit as x approaches 0 and then a little plus sign. That means from the positive side. So this is telling you, let's sneak up on 0 on our x values, but let's sneak up from the right side. So that means so as I was approaching an x value of 0 from the right, my y value is still equaling 5. This over here says limit as x approaches 0 from the left of f of x. Well, that's your left-hand limit. We're approaching from the negative side, which in math is the left side, and so that's what we did before. So we have what's called a right-hand limit and a left-hand limit. And the calculus definition, just hold on a second. Can't write and talk at the same time. And calculus has a specific definition of a limit. So this is very, very important. It goes like this. A limit exists. Let me pause this and write this out. Okay, I've written it out. You didn't want to sit and watch me write that. So I'm going to read it to you in words, and then we're going to go ahead and show it in math language. But it says a limit exists if the left-hand limit equals the right-hand limit at the given x coordinate. So at x equals 0, what we were just working on, the left-hand limit and the right-hand limit, they're equal. So we have a limit there. If I put that in math language, which is sometimes scary until you get used to it, the limit as x approaches any given x value of f of x is equal to the left-hand limit and the right-hand limit, assuming they're equal. All right? So now there's going to be times that they're not equal. So if this did not equal this, we would not have a limit. You would see this definition put in different forms, but just informally, you know that a limit exists only if the left-hand limit equals the right-hand limit. So with that background knowledge, let's start doing some more questions here. Okay, I've set up a couple new ones. So now you're pretty up on the vocabulary. This is the, be careful here because we're approaching -4, but we're approaching from the right-hand side. This negative means something very different than this positive or negative up here. So this tells me the x-coordinate in question is -4. There it is. We're approaching from the right. So I have to think about approaching -4 from this side. And I'm thinking about the y values. What's the trend in the y values? The y value is closing in on 0. Now I know what you're thinking. You're thinking, this is almost stupid. This is so obvious. I just look at the -4, x equals -4, and say, oh, it's a y value of 0, and I write down 0. Well, it's not going to be that clear-cut and obvious as we go on. Let's take a look at this. The limit as, The limit as x approaches 2 from the left. All right, so my x-coordinate is 2. There's something fishy happening at 2. I have to approach from the left. This is a very important lesson about to happen. As I approach 2 from the left, I'm doing this. I'm closing in on a y value. I'm getting closer and closer to a y value of 3 as my x value gets closer and closer to 2. So believe it or not, the answer is 3. But you're saying there's no way because there's nothing happening at 3 right there. And in fact, this function has a value of -1 at x equals 2. But do you know what? This doesn't matter, and this doesn't matter, because the concept of a limit says this. As I'm approaching 2, what is the trend in my y values? And the trend is, it looks like I'm closing in on a y value of 3. It literally doesn't matter what happens when I get there, because I never get there. I just approach 2. So this is a very hard hurdle to get over. This answer is 3. Now, this was a right-hand limit. This was a left-hand limit. So because they were specifically right and left-hand limits, I didn't have to worry about the true definition of a limit because I was just focusing on one of these parts. If, for example, they asked for the limit at x equals 2, and not approaching from the right or the left, so like that, then we'd have a different story. Then we'd have to think about the right and the left-hand limit. So as a service to you, I've decided that we'll take a look at some of those weird spots. So let's start off with this question. Does a limit exist at x equals -3? Well, here's my x value of -3, and you'll notice there's some crazy stuff happening on that graph right there. So here's how I would find out. I would first look at the left-hand limit, and I would ask myself, is it equal to the right-hand limit? That's going to tell me if I have a limit. So the way I would write out left-hand limit here is a limit as x approaches -3 from the left. of f of x, and then I would wonder, is it equal to the right-hand limit? Okay, so the way I've written this is the informal left-hand limit, right-hand limit. That's kind of like mathematics slang. This is the math language. So now let's look at the graph. As I approach -3 from the left, I'm closing in on 1. I'm wondering if it equals, let's approach 3 from the right. Here's my x value of 3, so to come from the right, I have to be on this section of graph. That's 2. 1 does not equal 2, so the limit does not exist. What I would write there, let's move this up a bit. I would say limit as x approaches -3. So now notice I don't care about left or right hand limits because I've already thought about that. Of f of x equals, I could say does not exist, or sometimes I'll do that, but there is no value. There's no y value that's being closed in on because we have this kind of argument. When I close in from the left, I'm approaching a y value of 1. When I close in from the right, I'm approaching a y value of 2. Limit does not exist. All right, let's look at this next one. Does a limit exist at x equals 2? All right, so at x equals 2, we've got some funkiness. We've got this dot down here. So that really means, by the way, the value, the function value of f of 2 is -1. But I don't care about that because I'm working on a limit right now. So I'm going to look at this informally instead of doing the specific math language in this case. As I approach 2 from the left, I'm closing in on a +3. So this is informal, and this would not fly for a math professor or an AP grader, but I'm going to do this one informally. Now I look at the right-hand limit. As I close in on 2 from the right, I'm still approaching +3, so I can say the limit does exist, and I can say the limit as x approaches 2 equals 3. Limit did not exist, limit does exist, and let's look at x equals 4. Okay, so here's x equals 4. We got this funky corner spot. Now there is not a value there. So if I said, what is f of 4? You would say f of 4 does not exist. There is no value at 4. But remember, we don't care in a limit. It doesn't matter what's happening at that point. It only matters the trend leading up to that point. So I'll go formal here. I'll do this, start with a left-hand limit. Limit as I approach 4 from the left, and now I'm going to do the right-hand limit. I bet you see where we're going. Thus, since the left-hand limit and the right-hand limit were equal, the actual limit, I'm not saying right or left, ta-da! All right, I've got 2 more weird situations for you here. Okay, I've set up a couple new problems, and if I look at this first one, the limit as x approaches infinity. What? Infinity? Yes. We can sneak up on an x value of infinity, so we're going like, but we would just keep going, and based on this graph, my y value would keep getting larger and larger. So you could have a value of infinity for a limit. And let's look at this last one. As x approaches negative 6. 1, 2, 3, 4, 5, 6. Okay, so that's this. So now we have a problem here. We've been trained on this video to say anytime I look at a limit value, I need to evaluate the left-hand limit and compare it to the right-hand limit. But in this case, this is an endpoint. I do have a right-hand limit. I'm going informal here. The right-hand limit is -2. But the left-hand limit is weird because I can't get to the left side of that point. There's nothing over here. So, in the case of an endpoint, you don't worry about it. You just take whatever you have, and in this case, my answer is -2. Check this out. I'm going to recreate this section of graph. Even if it did this, my answer would still be -2 because as I close in, I don't care what's there. There could be a monkey eating a taco on a bicycle and I wouldn't care. I only care about the trend in the y values as I get close to that spot, which is -2. All right, this was a long video. Thanks for hanging in there. They won't always be this long. But we had to get over the awkward concept of a limit is closing in the value of the y that is being closed in on as the x value closes in on a specific location. Talk to you later.